Hello, welcome back. For this next question, we've got a scenario, a school locker scenario question where we've got to write some pseudocode. So we'll have a look. In a school, there are 2,400 students, and each student uses one locker. Okay, each locker has a unique number from 1 to 2,400, one for each of the students. The lockers are to be painted 4 colours: red, white, yellow, and blue. And that depends on the order number shown in this table. So for example, come over here, locker number colour, 1 represents red, 2 white, yellow is 3, blue is 4, and then it repeats, okay, all the way up to 2,400. Where, as you can see here, blue would be 4, it would also be 8, and it would also be 2,400, okay, and all the numbers in between, which sort of are multiples of 4. The pattern of the colours continues in this manner. For example, locker number 15 will be painted yellow. Okay, state the colour that locker number 442 will be painted. Well, looking at this, it's some kind of it's a divisible question, a modulus question, which is seems to like when it comes to either div or mod when it comes to pseudocode questions. So, if we, without any code, if I use the bus stop method and go 442 divided by 4, because we're going to use mod 4 or percentage 4, yeah. Obviously that's 1. 4 goes into 4 one time, 4 goes into 4 one time, 4 goes into 2 0 times, so it'll be 110. And then because it's a mod, we're looking for this number here, the remainder, which in this case would be remainder 2. Okay, so the 110 4s, which would give us 444, remainder 2. So if that's the case, remainder 2, looking at the board over here, remainder 2, yeah, would be white. Okay, would be white. Well, what does that mean? Well, let me take another example. Let's try to get an odd number. If I go 191, okay, divided by 4, okay, sticking in divided by 4. 4's into 1, obviously can't go. 4's into 19 would be 4 4's are 16, so we go 4, okay, carry over the 3, yeah, so 4's into 31 goes 28, 7 4's, okay, remainder 3, okay, so 191 would give us a colour value of, because it's a remainder 3, would give us a colour value of yellow. Now if we've got something like 16, okay, 16 into 4, obviously goes 4, and there's no remainder 0, then that would be just like blue, just like 4, just like 8, that would be remainder 0 would equal blue. Okay, so we could choose any number. So 2010, okay, obviously goes into, doesn't go into that, but goes into 25 times, doesn't go into 1, goes into 10, carry the 1, goes into twice, okay, with a remainder of 2, which would give us, yeah, like we've got here, white, white. Okay, so we just do it that way. We just use divide and just to get the modulus. That's why it's only worth 1 mark. Okay. Okay, so we've got 1 mark. Tick. Each student is responsible for painting his or her own locker, their own locker. Some students do not know how to determine the colour they should use. Construct, in pseudocode, an algorithm that accepts a locker number as an input and outputs the colour that this locker should be painted. Okay, well I'm going to do this a long way round. So because it's pseudocode, I'm going to click start. Okay, and this is for this one. So I'm going to start it. I could create a function for this and then call the function at the end. Yeah, we'll do it like that. It's question 10. We'll do it as a function. Okay, so my function Yeah, it's going to be get locker colour. Get locker colour. And that's going to be based on locker num that I'm going to use. Okay, so the function is get locker call, depending on what the locker number is. So I'm going to declare in here, I'm going to declare with a mixture of capitals and lowercase, what am I going to need for this? I'm going to need colour. Okay, and colour is going to be declare colour as a string. Yeah, and I'm going to declare some questions say you do not need to declare anything, but it's always nice to sort of think about what variables you're going to use. Okay, so declare the colour as a string, and I'm going to declare, and I'm going to put in here, because I've been using remainder, I'm going to declare my remainder. That confuses the examiner, doesn't it, when you mix lowercase and uppercase letters. Declare remainder as a integer, because it's a whole number. Okay, so I've got what I'm going to be using. I'm going to be using colour, yeah, and I'm going to be using my remainder. So where do I go from here? Okay, well, we know we're going to use this bit. I'm going to say remainder, yeah, we'll do it all in the name. Remainder, lock, num, mod 4. Okay, so remainder equals locker number mod 4. Okay, so locker number divided by 4, what do we get as our remainder? Okay, that's going to be my first sort of line of code. Now, we're not going to put it into any kind of a while loop. I just wanted to do this once. We could put while locker is less than 2401, something like that. I'm not going to do a while loop in this. Okay, what I am going to do is just use a series of if statements. So, if remainder, can you see that? If remainder equals 1, then do what? Okay, the colour, yeah, I'm basing this on a function, colour, or colour with a, yeah, colour equals, I suppose it's got a U in it there, we're not American, well, some of you might be, colour equals, yeah, number 1, red. Okay, and we're just going to work through it like that. So if remainder is 1, then, can I move this up? I'm going to continue with else, if, yeah, remainder, the boring bit now, remainder equals 2, then colour equals 2 would be white. You see where we're going? Else if remainder, it's a nice easy one this, yeah, equals 3, then colour equals yellow. Okay, but we've got a final colour, we've got blue, and blue is when the remainder is 0. Okay, when the remainder is 0. So, what can we do for that? I could stick in an else, but again, just for the sake of it, I'm going to go, yeah, I'm going to continue with else if. You could put else colour equals blue, but then if somebody was to put a number in greater than 2,400, okay, a bigger number or something less than 0, I'm not going to factor that in at this point, but use else as a checker, and if the number is less than 0 or higher than 2,400, put a message saying, please enter a number that is between 1 and 2,400. But I'm going to leave that off. Okay, I'm just going to do this final one, remainder equals 0, then colour equals blue. Come in. Okay, so now once we've got the else if, once we've got all our colours sorted out, we need to end the if statements. If. Okay, so we started with an if, now we're going to end the if. Okay, and then I need to output the colour. So I'm going to return the colour. So I'm going to return the colour and I'm going to end the function. Okay, end function, because that should be in line with this. Okay, so I've got my function, declared my get locker colour, locker number. I've declared my colour, I've declared my remainder. Remainder equals block number. Okay, and then if the remainder is 1, 2, 3, or 0, do that. End the if statement, return the colour, end the function. So I've created a function, but I've got to call this function. So we need to work out how we're going to call a function. Yeah, how we're going to call a function in this. Red. So I'm going to call the function. Call function. Okay. I'm going to declare lock. Yeah. Lock num. Yeah, I think that's what I called it. Declare lock num as integer. Okay. And I'm going to output. Yeah. Enter locker number. Input. Get the user to input locker lock num, and then I'm going to output another message. Basically, how can we do this? Let's do it in words. Locker number lock num. Lock num. Just going to continue on the next line. Is painted, or should be painted, and then going back up. This is where we're going to call, yeah, our function. Yeah, get locker call block number. Okay, get, comma, get locker call. Yeah, and we're going to do that locker block num. Get locker call block num. Is that right? Yeah. Oh, locker num. It should be locker num. It should be locker number. Okay, let me just read that out. Okay. Sorry, I've just gone in a little, just done some little tweaks there. So, and then we just end. Okay, end it all. Let's see if I can zoom out of this and we can try and see where we've gone. Okay, so start and end. So I've called the function get locker color block number. Yeah, you can see this. If I do it like this. Okay, function get locker call locker number. Declare the color as a string. Declare the remainder as an integer. Remainder equals locker num mod 4. If the remainder equals 1, then the colour equals red. If it's 2, equals white. If it's 3, yellow. If it's 0, remainder 0, it would be blue. I end the if, I return the colour, and I end the function. Okay, now I call the function by declaring the locker number as an integer. Okay, I output enter your locker number. Okay, I input locker number, or the user inputs the locker number as an integer. Okay, output locker num, lock number. Okay, is painted, so this should be all on one line. Yeah, is painted. Get locker call block number. Basically, I've missed off that bracket. Okay, so this here, so this bit here, this bit here relates to, yeah, get lock call Yeah, get locker call locker number. Okay, that's my function, and this is how I call my function. You don't need to do it as a function. Naming variables, that's your important thing. Make sure your names are correct. I ran into a bit of a problem with locker num or lock num. Yeah, make sure the name and they correspond all the way through. But that would get us how many marks? Yeah, 5 marks. Okay. So declare the colour as a string, declare the remainder. Yeah, and then basically it's that bit. That's your important bit. Hopefully the exam paper will give you plenty of space. So the next bit, state the name who is responsible for painting locker number 811. So we've got 3 tables, okay? We've got 3 lists or arrays, okay? We've got 3 arrays, student name, locker number, painted, okay? Each one related to them. Each one's related to them because we've got an indexer here, okay? So Robert Abbott is at position 0, his locker is 561, so it looks like these have been scattered alphabetically, but maybe they're not in the same year group, or the lockers are sort of positioned all over the different parts of the school. So Robert Abbott, his locker number is 561, and it's been painted. Okay, he's at position 0. Sarah is at position 1, and she's sort of in the middle of the block. False, she hasn't painted hers yet. Ivy hasn't painted hers yet, she's at 811, position 2. And then Zaizi, okay, is at position 2399. His locker is number 45, so he might be in grade 7 or 6, and he has painted his locker. Good. Example, student name, position 1 is Sarah Anna. She's responsible for locker number 1256, and this locker has not been painted yet, okay? So for 1 mark, state the name of the student who is responsible for painting locker number 811. Well, 811, pen here, is obviously Ivy, yeah, and she's not painted her locker yet. So what we'd write in there is Ivy and Abbott, okay, for 1 mark. Okay, now constructing pseudocode, an algorithm that counts and outputs the number of lockers that have been painted so far. And we'll try and do this in an easy way. I'm not going to use a function for this. The function might have been a bit strange, so let's do it this way. I'm still going to do some declaring, so I'm going to declare now variable name. Declare count painted, count paint locker, okay, as integer. Okay, first line. Okay, so the count paint locker is going to be a number. It's going to be a whole number, and we're going to set counter, or yeah, let's call it paint count. Let's go back. Paint counter equals 0, and then we need a loop. We're going to loop around. So I'm just going to remove this bit. We need some kind of a looping system because we're going to loop through all the numbers, yeah, from 0 to 2,399. So loop through all the elements to see whether each locker has been painted or not. That's basically what we're trying to do. So while number is less than 2,400, we could do, but I think I'm going to use a for loop for this. So for, yeah, and we'll do it because it's pseudocode. We'll for index from, and this is where we're going to put our numbers in, 0, yeah, to 2399, do, yeah, from index from 0 to 2399, do what? Well, if painted, this is the table, yeah, this is this bit. If painted, okay, and this is where we use the square brackets. I'm using the index. I'm going to use the index here, okay. So if painted, index value, I'm using this, okay. if painted index equals, and I think it's spelled like this, equals true, then, yeah, if painted index equals true, then, what we're going to do, then, whatever, paint counter, yeah, referring back to this, paint counter equals paint counter plus 1. Okay? So I've declared that as an integer, paint counter equals 0. For index, do paint counter. Then I'm going to end the if, end for. Just going to move that up, because then we've got to do some outputting, haven't we, down here? We'll do some output. Yeah, just looking back, I thought I'd done it as a function. I haven't. So end for, and then all we're going to do is go output. Yeah, output what? What do we want to output? Output, I want to give a little message. Number of blockers painted equals paint counter. Okay, so it should gives a little message, and then it should give us whatever number we've got in the paint counter. Yeah, which at the moment starts at 0. Okay, so we loop round from 0 to 2399. We do this, we're basically just adding, is the index value true? Is the value true? Is the value true? All the way around, and then pass that into this little message here. Obviously, I didn't do a start on this one. Should have done a start. Let's do that. Start. And then end. Okay? So that would give us that scenario there. So that would get us, okay, another 4 marks. Construct pseudocode, an algorithm that counts and outputs the number of lockers that have been painted so far. Finally, describe an efficient algorithm which accepts a student's name as an input and outputs the corresponding locker number and whether or not it has been painted.
Hello.
You got a lesson?
Yes.
Okay. We'll do that next time. Okay, I'm going. Right, you are out. Thank you. Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.